All right, here we are with Psychrometrics. Instructor Raul Gonzalez is here. Is going to give us some basic outlines on it.
Today we're going to learn how to use the psychrometric chart and the tools, and how to use both of those tools and the psychrometric chart together. The first tool we're going to go over is the psychrometer. And what this does, it actually helps us find wet bulb and dry bulb temperatures, so we can use it to plot on the psychrometric chart. And the one on the top is the wet bulb temperature. The one on the bottom is the dry bulb temperature. You might ask me, what is the difference between wet bulb and what is the difference between dry bulb? Dry bulb temperature is just the temperature of that particular room or air sample. Wet bulb takes into account the humidity content in the air, how much humidity can be evaporated into the air. So what I'm going to do, I'm going to plot it on the psychrometric chart. So let's see here. Wet bulb is 63.9 and dry bulb is 73. So what I'm going to do, I'm going to go up on the board. Hopefully this thing writes. Okay, my dry bulb 72.8 and my wet bulb 633.6. Before I get started, I need to explain something. Your wet bulb should always be lower than your dry bulb temperature. And you might ask me, why is that so? If both these numbers are the same, that means there's 100% humidity in here, and it's probably raining, or you see condensation forming on the ducts or at the wall, which is a big problem because, as we know, air conditioning not only cools the room, rephrase that, removes humidity from the room and brings the temperature down, but it also has to dehumidify the temperature in that room. So what I'm going to do is first plot the dry bulb temperature. And you may say, okay, how do you plot the dry bulb temperature? Well, on the bottom here, 20 all the way to 110, that is the dry bulb temperature. The dry bulb goes up and down, so let's look for 72.
Now these students can find it on their PDF version of this.
Yes, they can, and I'm going to give them a chart or a PDF version in their table so they can use it to follow along, so they can learn how to better use the psychrometric chart. So right now, we had 70, and this is 75, so 72, 71, 72 is around here somewhere. Obviously, it's better to use a ruler, but I don't have a ruler for the board, but the straighter the line is, the more accurate the plot's going to be. So right now, this is the dry bulb temperature, and I also need the wet bulb temperature. Now you see these lines right here that says 25 all the way to 80? That is the wet bulb temperature. And the wet bulb is on a 45-degree angle. So okay, let's find it, okay? 60, 65, so 61, 62, 63, and somewhere around here is 63.6. Am I done? No, because the main purpose of the psychrometric chart is to see how much humidity and moisture content is in the air. So my first thing I need to find out is my percentage of humidity. Most people are comfortable with 50% to 55%. So let's see if this air is comfortable for the people that are inside this room. So right now, let's see, the dot's right here. This is the 50 line, 50 line. This is the 55, so it's around 51% or 52%. That's pretty good. This thing's not working right, Oscar.
Just use the regular marker.
Okay. So I'm having technical difficulty with the pen, so I'm actually going to switch back to a regular pen. So it's 51%. That's pretty good because it falls into 50 and 55%. So the people that are in the room are going to feel comfortable and not feel uncomfortable sitting here. Am I done? No. I also need to find something called dew point. Does anybody know what the dew point temperature is, or what is that dealing with? The dew point temperature is when condensation starts falling out of the air, or condensation in the air. So if you ever gone to a restaurant or school or a commercial building or even in your house and you see your ducts or grill sweat, that means that grill is below the dew point temperature. So let's see what temperature where water starts condensing out of the air in this air sample. So basically the dew point temperature is the same as the wet bulb. The only difference is it's in a straight line. So 56, 57, 58. Around 58.1 dew. So you might say, okay, well, we found it. Why is that important for me to even know that number? Because if I get the duct below 58 degrees, it's going to start condensating, which is a big problem because it can create mold. So I need to keep the airflow high enough to make sure that the air does not get below 58 degrees. So if I'm having a sweating duct problem, that means that I need to increase the airflow because it's below the dew point. Now I'm going to find moisture content per pound of dry air. So believe it or not, even though air feels dry, there is moisture in the air. And the job of the AC is to grab the humidity and take it outside. So we need to know how many grains of moisture is in here. So what I do is go back to the point that I started with and go all the way to the right. Which means that this has around 69 grains of moisture per pound of dry air. Later on, in the advanced video, we're going to actually plot a return and supply to see if the AC is actually removing the proper amount of humidity.
Excellent.